Hi, good evening everyone. Today we are discussing the continuation of the mean value theorem. Now the second theorem is Lagrange's mean value theorem. The definition and the rules we have to follow. Let f of x be a function such that the f of x is continuous in closed a comma b and it is differentiable in open a comma b. Then there exists at least one point c belongs to a comma b such that before we see that in Rolle's theorem there is f dash c is equal to 0, but here it is changes f dash c is equal to f of b minus f of a by b minus a. If the all three rules are correct, then the Lagrange's theorem is applicable for the given function. Here the mainly change between the Rolle's and the Lagrange's is f dash c. Here f dash c is equals to f of b minus f of a by b minus a. Next we see the problems on it. Now here we can see the question, that is, now here we can see the question, verify LMVT for f of x is equal to x cube minus x square minus 5x plus 3 in the closed 4 comma 0. The given function, it is a polynomial, then it is continuous, in 0 comma 4, closed 0 comma 4. It is a differentiable in where the interval, that is open 0 comma 4, and the next is differentiable. Then we have to differentiate the function 3x square minus 2x minus 5. It is a differentiation of the function. For the x cube, the differentiation is 3x square. For x square, that is 2x, and minus 5x, that is minus 5. And the next what we have to do is, next we have to, by the LMT, we have to find the value of the c. That means first we have to get f of b. What is f of b? On substituting the value of 4 in the f of x, we get the f of b. F of 4 is equals to 4 cube 64 minus 16 minus 5 into 4 plus 3. The answer will be 31. And f of a, here a is equals to 0, then 0 cube 0 square and 5 into 0 plus 3, answer will be 3. And the next what we have to do is, next by using LMVT, f dash c is equals to f of b minus f of a by b minus a. We have to substitute the f of b and f of a and b minus a here, and equating this to the f dash c. The next line, 3c square minus 2c minus 5 is equals to 31 minus 3 by 4. It will be becoming 28 by 4. It will be the 7. And the next 3c square minus 2c minus 5 plus 7 is equal to 0. 3c square minus 2c plus 2 is here it is plus, and then it will be becoming whole minus, and it is 12. And next, on solving the above equation, we will get the value of c is equals to c1, that is 2.360, and c2 is equals to minus 1.694. Here 2.360, that means c belongs to open 0 comma 4. Hence LMVT is verified. Like this manner we have to solve the many problems, and we see the next problems also. Next, for the next question, the f of x is equals to log x base e in the interval of closed 0 comma 6. Next we have to solve f of x. It is a logarithmic function and it is continuous continuous in 1 comma e, and it is continuous. It is continuous in closed e comma 1. And the next differentiability we have to check. It is a differentiable in open 1 comma 6. Then we have to differentiate the function f dash x is equals to d by dx of log x. That will be the 1 by x. Therefore it is differentiable, and the second statement also true. And we have to go to the third. Before going to third, we have to check f of b. Here b is equals to e, and log e base e, that will be becoming 1. And the next f of 1, log 1 base e, it will be becoming as 0. And now by using LMVT, we can get that f dash c is equals to f of b minus f of a by b minus a. Here we have to substitute the values. That is equals to 1 by x is equals to what it will become, 1 by e minus 1. The next we have to, here it will be c, and the c is equals to e minus 1. This is belongs to the open e comma 1. Hence LMVT is verified. These are the two problems which is we verify the LMVT theorem, and the next we see the different problems, how we have to solve them. Now let us considering the next problem. Calculate fifth power of 245 using LMVT. We have to find the value of fifth root of 245 by using the LMVT theorem. First let us consider f of x. Here they are not given f of x. In the place of f of x they given the 245. Then we have to consider that x power 1 by 5. Here x will be the 245, and the next it is a polynomial, and they already verified it. Then next we have to differentiate it. F dash x is equals to 1 by 5 into x power minus 4 by 5. It will be the differentiation. By using LMVT, we know that f dash c is equals to f of b minus f of a by b minus a. And the next we have to, here we have to consider the values, that means the 245. It will be b, and the a is equals to, either you consider 243 or 241, any values with the less difference we have to consider it to get the accurate value. Here by substituting here, then we will get f of c power minus 4 by 5 and f of 245 and f of 243 and b minus a. 245 minus 243, 5 c power minus 4 by 5 f of 245. Here the 3 power 5, it will be becoming 243, and it will be becoming now 2, and then cross multiply, and we get 245 into, here this 3 plus 2 by 5 c power minus 4 by 5. Here the c lies between the 245 and the 243, we know by using the LMVT, and f of 245 is equals to 3 plus 245 into 244 whole power minus 4 by 5. Then the total is value becoming 0.0049, and adding them 3.0049, and finally this is the value of fifth root of 245. We got the value. Now we are going to see the second on the different model, and Here the problem is a greater than b. Prove that b minus a whole power 1 plus b square is less than tan inverse b by a minus tan inverse a less than b minus a by 1 plus a square. Then what we have to do? Then first we have to consider let f of x. What is f of x? We have to consider that is equal to tan inverse x. It also satisfies the LMVT. Then f dash x. What is the f dash x of tan inverse x? That is 1 by 1 plus x square. And the next what we have to do by using LMVT. What is f dash c is equals to f of b minus f of a by b minus a. Here the f dash c is 1 by 1 plus c square and f of b is tan inverse b minus tan inverse a by b minus a. What we need tan inverse b minus tan inverse a in the question. Then we cross multiply it. Tan inverse b minus tan inverse a, that is equals to b minus a of 1 plus c square. Hence it is the value, and then by we know in the starting they give the condition a less than b, and by considering that what we have to do, that is a less than b. By using LMVT, the c value must slice between them. By that a less than c less than b, and by now in the next step we have to square it first. A square less than c square less than b square, and the next what we have to do, we want 1 plus c square below. By adding for all we have to add 1 plus a square plus 1 plus c square less than 1 plus b square. Next we have to do the reciprocal of the numbers. Then the symbols will be changes. 1 by 1 plus a square is greater than 1 by 1 plus c square is greater than 1 by 1 plus b square. And now we interchange this both according to the problem what we require. Then also the signs will be changes. Is less than 1 by 1 plus c square is less than 1 by 1 plus a square. Now what we have to do is, here 1 by 1 plus c square, we have already know the value of 1 by 1 plus c square. By using the LMVT we proved that tan inverse b minus tan inverse a by b minus a. Then we have to substitute it in the equation. 1 by b 1 plus b square is less than whole value tan inverse b minus tan inverse a by b minus a, that is less than 1 by 1 plus a square. Here by we are cross multiplying it on both sides. B minus a 1 by 1 plus b square is less than tan inverse b minus tan inverse a by b minus a less than b minus a 1 by 1 plus b square. Here we proved the condition what we require. Then and the problem is some more. Then we have to deduce the value. Then what we have to take from the above equation. Here we have see that we have to take the value of a, that is 1. Why? Because the tan inverse pi by 4 it will be becoming 1. So next the b is equals to, here it look like just tan inverse b. Here the b value is 4 by 3. Then we are substituting these values in the above equation what we have deduced. Then we will get 4 by 3 minus 1 by 1 plus 4 square plus 3 square, which is less than tan inverse b minus tan inverse a by, here by 1, there is nothing else, no problem. 3 minus 1 by 1 plus 1 square. Here by calculating the whole term will be becoming 3 by 25, and tan inverse 4 by 3 minus tan inverse 1, it will be becoming, it will be equals to the pi by 4, the total. The next step we have to change it, and the next is it will be becoming 1 by 6. Then here we have to both sides add the pi by 4 to remove this pi by 4. 3 by 25 plus pi by 4 is less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. Hence we reduced the required equation and required condition. Then again one more reduction. 5 pi by 4 by 20 is less than tan inverse 2 is less than pi plus 2 by 4. Now here we can see, here we have to separate it. Pi by 4 plus 1 by 5 is less than tan inverse 2 is less than pi by 4 plus it will be becoming 1 by 2. Here a is equals to what we have to take a, here also same pi by 4, then a is equals to 1, then b is equals to 2, same as how we did in the above. Then we have to continue below also. Then b minus a, 2 minus 1 by 1 plus 4, that means a square, and tan inverse 2 tan inverse 1, and here b minus a, 2 minus 1 by 1 plus a square, that means equals to 1 square. Here we will getting, this will be becoming the pi by 4, this value, and it will be becoming 1 by 5 is less than tan inverse 2 minus pi by 4 is less than 1 by 2. Then we have to shift both sides, we have to add pi by 4, 1 by 5 plus pi by 4 is less than tan inverse 2 is less than 1 by 2 plus pi by 4. Hence we deduced the required equation, and now we have to take the LCM. Here LCM is 20, and then 5 pi plus 4 by 20 and tan inverse 2. Same here also the LCM is 4 and pi plus 2. Hence we deduced the two equations here. Thank you for watching. In the next video there will be, here the LMVT is completed, and the next is the Cauchy mean value theorem. We will continue in the next, and there is some homework problems you have to solve, and we can find the answers on the website as the follows. Thank you for watching.